Okay, the second fundamental theorem of calculus. Again, this one's, that's derivatives. This is a really simple concept, but just wanted you to know exactly what it is, how it works. Now, if f is continuous on AB, then the derivative of the integral of f of x, or sorry, the derivative of the integral will be our function. So, the derivative, df over dx, the derivative of the integral should give us the function f at x. Okay? Yes, but there's a but there, and that's why I'm going to go through this. So I want to do these two questions with you, and I want you to see why it works. Okay? So the first thing we're going to do is we're going to do dx. Now we do the integral of cos t. It should be sine t from 1 to x. So we're going to do the derivative of sine x minus sine 1. Okay, what's the derivative of sine x? Is cos x. What's the derivative of sine 1? 0, right? Okay, so when you do the derivative of an integral, it kind of makes sense we get back the original, right? Now, here's where you have to be careful though. If anything other than x is in here, it complicates the issue. So, let's do it. So we've got d over dx. The integral would be 1/2 t squared minus, just because I'm going to be putting numbers in, I always, minus 4/3 t cubed from 0 to 3x to the 4th. So let's plug it in before we do the derivative of it. That'd be x to the 4 to the 2 minus 4/3 3x to the 4 third. Okay, we'll shut that bracket, minus. Now, when you put in 0, we don't have to do all the work, do we? You would get 0 in that case. But even, no matter what number you put in, so if the lower is a number, it always goes away after you take the so you really don't have to worry about it much. So this would be yes, yeah. So if I do the derivative of this now, let's do the derivative of this. Everybody with me here? Everybody watching? This would be, the 2 comes down, correct? To be 3x to the 4, which would be like to the 1, correct, right? But what do we do? Doing the derivative, we'd have to do the chain rule plus 3 would come down. That would be negative 4, 3x to the 4 Or, oh yeah, I'll just do minus. How's that? Okay. Minus that's squared times 12x cubed. Now, if we factor out 12x, actually we're gonna go like this, 3x to the 4 minus 4 times 3x to the 4 squared, and I'm gonna factor out 12x cubed. I could, but I wanted to more show you what happens when you take the derivative of an integral that the upper limit is not x. Okay, the first thing is I think people can understand is 3x to the 4 will be inside. But we always will have to have the derivative of that upper limit at the end. Okay? So when you take the derivative of an integral, if this is x, then it becomes f of x, right? But if the upper is anything but x, you substitute that in, right, to t, but then you must also do the chain rule, so this will all be multiplied by the derivative of the upper. Okay? So let's do this quick. We'll do these together, right? Because these are super fast if you know what you're doing. Okay? So what would be the derivative of this integral? What would be the final answer? 1 minus x cubed. Okay? The next one would be 1 minus, now let's put that to be x squared cubed times 2x. So this would equal 1 minus x to the 6th times 2x. Yeah, but I wanted to, you know what, I get it, we could put it in the front, but I want you to see, put it in and always multiply at the end by the derivative of that upper limit, okay? Okay.
Please excuse the interruption, students.
Okay, this one, so this would be 1 over 1 minus cube root x. Okay, 4 would be x squared over sine x squared times 2x, which would equal 2x cubed over sine x squared.